Hi everyone. So in this video, we are going to discuss the topic of power consumed in AC circuits. Okay. Now suppose you have an AC circuit with an AC source. Okay, this is the AC source and it is connected across a device. Now this device D. Okay. Now this device, it can be a resistor. Okay, it can be a resistor. This device can be a capacitor. This device can be an inductor. Okay, it can be any device. So we are taking a general case. Okay, so you have a device and you have a AC source. Okay, now let's say this AC source has voltage V is equal to V naught sine omega t. Okay, and the current that is flowing in the circuit, now it can be anything. See, it can be resistance, it can be capacitor, it can be inductor. Now in resistance, current and voltage, they are in same phase, but in capacitor and inductor there is a phase difference of 90 degree. Okay, in case of capacitor, current is ahead of voltage by phase angle of 90 degree. In case of inductor, voltage is ahead of current by phase angle of 90 degree. So now let us take a general case where the phase difference is phi. Okay, and let us take the current I to be equal to I is equal to I naught sine omega t plus phi. Okay, so this phi is the phase difference between instantaneous value of voltage and instantaneous value of current. Okay, now let us calculate the power consumed in this circuit. Now the work done by the source, this source, work done by the source in time dt. Okay, suppose dw is the work done, dw is work done in time dt. Okay, then I can write dw by dt, that is rate of doing work, that is power. Power is a product of voltage and current, isn't it? So we have dw, it is equal to vi dt. Okay, so this is dw, it is equal to v is v naught sine omega t, I is I naught sine omega t plus phi dt. Okay, so we have this expression for dw. Okay, and we have to simplify it to get the value of work done, and from that we will get the expression for power. Okay, so we have this equation for dw. Okay, now let us rearrange these terms a bit. So this v naught I naught, we'll write it together, v naught I naught sine omega t, and let us expand this. So this is sine omega t cos phi plus cos omega t sine phi multiplied with dt. Okay, so this is v naught I naught sine square omega t cos phi, this multiplied by this. Okay, then plus this multiplied by this sine omega t cos omega t sin phi dt. Okay, dt is for the entire terms. Okay, so dw, it is equal to v naught I naught cos phi sin square omega t dt. This dt is multiplied with this. Then this thing can be written as plus 1 by 2 sin phi sin 2 omega t dt. Okay, this sin omega t cos omega t is written as sin 2 omega t, and then this is divided by 2 because 2 sin omega t cos omega t is sin 2 omega t. Okay, now this is dw. Now from this we can get the value of w by integrating the other terms. Okay, so let us integrate it. So this is this is 0 to w, this total work done in one time period. So 0 to t, this is 0 to t. Okay, acha, now if you integrate this term, okay, from 0 to t sin 2 omega t dt, this will give you the result 0. And again this term is constant, so if you integrate this, you have to integrate this sin square omega t from 0 to t, you will get the result as t by 2. T by 2. Okay, now let me show you this result in the next page. So first let's see how 0 to t sin 2 omega t dt, I am saying it to be equal to 0. Okay, now sin 2 omega t is minus cos 2 omega t by 2 omega, limit is 0 to t. Okay, so this is equal to minus 1 by 2 omega cos 2 omega t minus cos 0. Okay, now this omega is twice pi by t. Okay, so this t and this t gets cancelled, so this becomes cos 4 pi. Okay, now cos 4 pi minus cos 0. Cos 4 pi is 1, cos 0 is also 1. So 1 minus 1 is 0. 0 multiplied by this gives 0. Okay, so we have verified this. Okay, now let us verify the other integral. So we have 0 to t sin square omega t dt, and I wrote the result is to be equal to t by 2. So let us check this result also. This is, I can write this as 0 to t sin square omega t dt. I can write it as 1 minus cos 2 omega t by 2 dt. Okay, so this is 0 to t 1 by 2, I am taking it outside, dt minus 0 to t cos 2 omega t dt. Okay, now this second term is again 0. This is similar to 0 to t sine to omega t dt. So this is equal to 0. Okay. Now if you integrate 0 to t dt, this is t, so t divided by 2. So this is equal to t by 2. So hence this result. Okay. So now let us go back. So we had this term as t by 2 and this term is 0. Okay. So now let us further simplify it. So this becomes W is equal to V naught I naught cos phi. This cos phi, and this is t by 2. So t by 2. Okay. So now this can be written as W by t is equal to V naught by root 2 I naught by root 2 cos phi. What is work done by time? This is the average power. Okay. So we have average power, P average. It is equal to V naught by root 2 is VRMS. So VRMS, IRMS, second quantity is IRMS multiplied by cos phi. Okay. So this is the expression for the average power consumed in one cycle. VRMS, IRMS, cos phi. Okay. Now this phi is the phase difference between voltage and current. Okay. Now this term cos phi, it is called power factor. Power factor. Okay. Now see, for AC applied through capacitor or inductor, phi is 90 degree, and when phi is 90 degree, average power will be 0. Okay. So say for inductor and capacitor, that device D, that general device D, which we have represented in the circuit initially. So if that device is either an inductor or a capacitor, for both cases phi is equal to pi by 2 radian or 90 degree. Okay. So in that case, average power, it will be equal to 0. Okay. Average power consumed is 0. So see, in this case, current is flowing, but even then the power consumed is 0. So that kind of current is called wattless current. Wattless current. Okay. So wattless current is the current for which average power consumed is 0. Okay. For in case of resistor, this phi is 0 degree, because in case of purely resistive circuit, voltage and current, they are in same phase, so cos phi will be 1. So for purely resistive circuit, the average power consumed will be VRMS and I multiplied by IRMS. Okay. Now this is the general expression. Okay. But in exam, you may be asked, like, prove that average power consumed in a purely capacitive circuit is 0, or purely inductive circuit is also 0. Okay. So for that we will discuss in the later part. Now first part is this general expression. Okay. So I hope this part of the deduction is clear to you. Now next, suppose in exam it is asked, like, show that average power supplied to an inductor over one complete cycle is 0. Now next, let us see, like in exam, if it is asked that prove that average power supplied to an inductor over one complete cycle is 0. Now, if this question is asked for 1 mark, okay, then you can write P average is equal to VRMS IRMS cos phi. Okay. Now, for purely inductive circuit, phi is equal to pi by 2. So, cos phi, it will be equal to 0. So, average power is 0. Okay. For 1 mark, this is enough. Okay. But now, if this is asked for, say, 2 or 3 marks, then this will not be sufficient. Okay. Then what you will have to do? Now, let us see that. Now, for purely inductive circuit, that is circuit with only inductance, no resistance, no capacitance. Okay. Now, suppose the voltage is V is equal to V naught sine omega t. Okay. Now, if this is the voltage, what will be the current? Current will be I naught sine omega t minus pi by 2. Okay. Why this is like this? Because in purely inductive circuit, current lags voltage by pi by 2. Okay. So this we have already seen previously, that in a purely inductive circuit, current lags voltage by phase angle of pi by 2. So here voltage has a phase angle of omega t, and current has a phase angle of omega t minus pi by 2. So this minus pi by 2 shows that current lags voltage by pi by 2. Okay. Now, instantaneous power, P instantaneous, it is a product of voltage and current. Okay. So it is, voltage is V naught sine omega t, current is I naught sine omega t minus pi by 2. Okay. So P instantaneous, it is equal to V naught I naught sine omega t. Sine omega t minus pi by 2 is minus cos omega t. So we can write P instantaneous as minus I naught V naught sine omega t cos omega t. Okay. So this can be further rearranged as minus I naught V naught by 2 sine 2 omega t. Okay. So this is instantaneous power. Okay. So now if you have to take the average power from this, so then we have to take the average value. Okay. So average value means this is a constant. So we have to take the average value of sine 2 omega t. Okay. So this is minus I naught V naught by 2. Average of sine 2 omega t is, for one cycle, that is, it is 0 to t sine 2 omega t dt divided by total time t. Okay. Now we have already solved this integral and it is equal to 0. So 0 multiplied by this quantity, that is P average, is equal to 0. So average power consumed in a purely inductive circuit, it is 0. Okay. This is for one complete cycle. Okay. So this is the proof. Average power supplied to an inductor over one complete cycle will be 0. Now this we have to write if the question is asked for like 3 marks or 2 marks. Okay. Now similarly, for purely capacitive circuit, you can try it on your own. Okay, there the current will lead the voltage by phase angle of pi by 2. So in case of purely capacitive circuit, current I will be I naught sin omega t plus pi by 2. Okay, voltage will be V is equal to V naught sin omega t. So then you can proceed in the similar fashion and calculate the instantaneous power. Again, the average power will be 0. Okay, so this is how you have to proceed if the question is asked for 3 marks. Okay.